All right. This, if you think about what we've been doing up until this point, we've just been capturing data, printing it back out, right? Next, like last week, we went through and we started capturing data, doing calculations with it, correct? The first assignment we did last week was just calculate and print out. Didn't do a whole lot with it. Then from Wednesday and Friday, we started doing examples where we captured data, we calculated data, we accumulated it with total lines, printed all that out, correct? Okay, that's probably what we're going to be doing, something similar to that again, just a little more in depth with the program on Tuesday. So we will have lab again tomorrow on Tuesday. But we're to the point now, we've done enough examples with that. We need to roll this into working it a little bit more. We need to go through now and start working with what we call logical comparisons. And if you think about the two major building blocks that we have in computers, calculations are one. The other major building block is what we refer to as comparisons or logical comparisons. In every programming language, that equates to a thing called an if statement. Okay, so I'm going to draw it on the board a little bit. I don't know if you guys will be able to see it, but on a breakdown on an if statement, we just come through here and ask one thing. And with an if statement, what we're trying to get is an answer of either true or false. Okay, and this is where it's my redneck term. It's the difference between thinking and thinking. You know, this is where logic we start throwing into the equation, and this is really where our problem solving starts coming in. Okay, and so by default we have an if statement that's set. Well, I'll do it over here typing, that way people can see it better when I'm doing this. So if I record it, hello Noah. So I'm going to come through here and I'm going to just do an example. Okay, I'm going to say if on this parentheses here, I'm going to say if age. See, it doesn't have a variable yet, so it's going to give me an error. Got a question? Toby, got a question? Oh, okay. So I'm going to come through here and I'm going to define a field just so I don't get errors, okay? And then I'm going to come through and say something like this. If I want to come through and say, all right, I'm looking for everyone that is greater than 21, okay? So what I've got here, and this is just a logical comparison, I've got two values that I'm dealing with, right? In this case, I've got a variable called age, correct? And I'm going to compare it to a second value. In this case, the second value is what? 21. It's a constant value, correct? I could come through here and say, well, if age equals num or something. I can also do, well, num's not defined, but if I wanted to put a second variable out here, I could compare it to another variable value. It can either be constant or a variable, right? And we have logical operators. This one right here, logical operator. So I'm going to come through here and write it like this. If variable 1, whatever my logical operator is compared to variable 2, which variable 2 could be a constant or another variable name, right? Okay, so logical operators, we have 6 of them. What are they? We've got one right there. Okay, we have less than, greater than, less than or equal to, greater than or equal to. We have equal, right? This is the one that throws everybody the first time they ever deal with C, with Java, with C#. A logical equal is equal equal. It's 2 of them, okay? The reasoning why, if I just use an equal sign, what am I doing?
That is that.
Yeah, it's an assignment. I'm saying, hey, this value is going to be equal to whatever this answer is, right? Or this calculation. So be careful Logical equal is equal. Okay. And so the only one we have left is what? Not equal. It is exclamation equal. Okay. So if I wanted to come through here and say, hey, I want to write this age. I want if age is not equal to 21, that would be a valid if statement, correct? Because I'm looking for not equal. If I'm wanting what? Equal, I'm dealing with equal. And most of these work really great with numbers. So if I'm dealing with integers, or if I'm dealing with double, right? Those work great. But you've already been working with some of this stuff. Can I also do this with strings? If states equal to Oklahoma, right? If I want to know who all's from there. You can and you can't. There's very few situations you could use it, but to the computer, remember, an A is less than B, correct? And a B is less than C. So yes, we can do those. If we go back to older ways with comparisons on strings, I can sort based upon greater than or less than. But it's really neat because now we've got one that just says dot sort and it takes care of it for us. It's a newer type of operator for us to do it, but old scale.
You could have like all the abbreviations of the states have less, make it
Greater than, less than, and it'll alphabetize them. Okay. Right now, and here's the deal. That works really good if you have at least 2 or more characters. So like states would work great. But right now we're using kind of a version of this because, whoops, let me go back up here. Because right now when we do, guess I hit it too many times. When we do our while loop, right now we're doing while yn what? But how are we doing the equal there? We do the dot equals. That is a type of comparison or a logical operator, but it's a string comparison. And the reason we do it is because it gets confused sometimes on whether it captures the inner key or not. So if we only use that one character, dot equals is the way we want to go. But that's the same thing as me coming up here saying yn equal quote end quote, right? So if I came up here and set up another data field for string, right? And I said yn and I gave it a value, correct? Why did I put it inside quotations? What's its data type? It's string. So if I were wanting to, I could really theoretically try to do this. If yn equal quote end quote, it's kind of the same thing, right? We're checking for equal. One just does a binary and one does a string compare. It's a different type of comparison. So how does this help us? Now we have multiple comparisons that we can do. Before, every program had, everybody did the exact same calculation, right? Now we can have multiple different calculations to determine things. We can determine if everybody's from in-state tuition, out-state tuition. So we can rewrite a whole lot of these programs. Okay, so the best way to do it is let's go through and do an example and work our way through it. All right. And it's best to talk about it as we're doing it. So here you go. I've got, let's say fictitiously, I've got a book publishing company. Okay. And I'm going to read in, let's say, ISBN number. And what's an ISBN number? It's the number, it's the universal numbering for your book, right? Okay, so probably need to make that what kind of data? If I make it integer, it's gonna be too long. Plus, there's some of them actually have numbers. Some actually have hyphens and stuff like that. So we'll probably go ahead and make this one a string field, correct? And then I want to read in how many pages are in this book. So we have people that bring me, hey, I wrote this book. I want you to publish it for me. How much you gonna charge me? Yeah, let's say we just go with it. But regardless, I own the company, I'm just gonna print it, right? So let's say if your book's real small, all the way up through 200 pages, I've got a flat rate of $4.75 as my cost to publish that book. Okay? But the more pages you make, so in other words, 201 on up to what? Let's say 500 pages. It's $4.75, and that's for the cost of the first 200 pages. Each additional page is 2 cents each. Okay? But if you have a book that has 501 or more pages, right? $10.75 plus 1 1/2 cents for all the pages that are over what? 500. So the more pages they have, what do we get? A little more discount, right? So somehow I've got to write a program to do this that has, I'm going to capture these two values, but I want to print out all three, the cost. Does that make sense? So if we look at this, what field am I going to use? Because really, I've got 3 different formulas to calculate, correct? What field am I going to use to determine what calculation I'm going to use? It's all based upon what? So if I said I have 300 pages, what's my answer? Right. We'll have to create an equation for that one, but we'll want to use this middle equation, right? Okay, so let's go through and work this. This is kind of the best way to go through and do this, is just start off and go, right? So integers, we're going to have what? Page, right? Okay, that one's good. We're going to have ISBN. Whoa, ISBN. That's going to be my ISBN number, right? YN. That work? Okay, pages is integer, so we're going to also have what? S page, right? Okay. Double cost. Probably won't have any more than that, will we? Because we'll have a decimal fraction here. So if, even though we multiply this and pages and the integer, we'll still get a decimal, right? When we talked about mixing the modes. Okay, so that should do it for us. So now I want to come through and do what? While what? Not ends with. And this one's going to be what? Okay. So after I do this, I turn around and start my bracing, correct? Okay. So I've got to capture 2 fields of data, right? So I'm going to have what? Close enough. Read line. Then come back and capture the second one. And this one's going to be what? So far, so good. Pages was our string version, correct? Or was it S pages? S page, I think is what we did. I didn't put an S on it. So S page is equal to what? Okay, and then if I want to go ahead and throw it into numeric form, I say what? Page equals, it's integer though, right? Int dot parse, and this fields is what? S page. Okay, so we got everything in order that we need to, this is normally where we'd come through and start calculating, right, Tristan? So before we can calculate, we got to determine which formula, correct? Which one would be the easiest thing to check for first? I mean, if you look at this, I like always starting there, but can't I start there? Because logically, I'm going to show you two different, well, yeah, I'm going to show you two different ways to do this, but really, no, I'm not. I'm just going to show you one because I don't want to confuse you with the other. Okay, I'm going to deal with what I call a block if, meaning no matter what, each pass through the loop, if I really have to ask 3 questions on where do the pages fall in, I only want 1 true and 2 false, right? So watch this. Let's do the first one. It's the easiest. If pages is less than or equal to what? 200. Okay. If that's the case, what do I want to do? I only have one thing to do, right? This is going to be a little bit confusing, but bear with me. Right here, I would come back and say cost equals $4.75, correct? And I got an error because I said pages instead of what? Page. Here's the problem. And this is where it gets kind of confusing, all right? So you with me here? If the answer or the result of this is true, what am I doing? I'm calculating the charge, correct? But I do it on one line. Correct? If I'm doing it on one line, I don't have to do bracing. Later on, if this answer is true, we might be doing 5, 10, 15, 20 different things, right? And if that's the case, it all has to be inside what? Our bracing. So this is where I say it's kind of confusing. It's a little cumbersome right now, but to get you in the habit of doing things like that, you can go ahead and do that. No, not that one. That. Even though it's just one thing, I put it in bracing, correct? And it's just kind of a habit. If it's only one line, you don't have to. But because it can go both ways, people kind of get confused. Okay. So that is called a resulting statement. In other words, if the results of this comparison were true, I'm doing everything inside the bracing right below it. If it's false, then it says don't do that, right? There's a thing right here called an else. If this equation's true, do this. If it's false, I'm going to drop down and do something else, right? Well, if it's false, I know one thing. What is that? My pages are greater than 200, right? Is there any need to check that? Because if it falls through, we know it's what? At least 201, right? We know it's greater than 200. And in this case, we don't have 200.5 pages, do we? So now if it falls through, I want to turn around with another if statement. This is called a block if. And if this is the case, I want to check the middle one, right? So if that's the case, what do I do? So if it falls through here, what do I have? Ooh, this is where it gets hairy. Now we have to start using math, isn't it? If I said you had 300 pages, what's the cost of my book? I'm losing faith in you, especially my engineers. How many pages over 200 do you have? 100, right? 100 pages times 2 pennies is what? $2. $4.75 plus $2 is what? $6.75, right? You can do it in your head, but how are we going to write that equation to do that? There's my 475, correct? And I'm going to have to add to this. I need to determine how many pages I have over 200, correct? So can I just say page minus 200 and then multiply that answer by what? 0.02. So if we look at our order of operations, what's going to take place first? It's going to find out how many pages I have, and then it multiplies next, and then it adds that result back in, correct? We refer to it as the hierarchy of operations in computers, but in math, we call it the order of operations, right? Sometimes the hardest things you have to do is convert an equation into a single line equation, but keep the order correctly. Rarely will I ever ask you to do anything harder than this. And if it is, I'll give you the equation. But I want you to understand how we got it, okay? So if that's the case right here, what am I doing? Does it matter if I put 475 first or last? Could I not come through here and do this? Page minus 200 times 0.02 plus 475. Doesn't matter how you type it up because the order of operation is going to determine the sequence of it, correct? Okay, so there we go. That's true there. So we've got two if statements. Go ahead. There's an if and an else, and then there's an if else, two different things. Those are two different things. There is an if else, else if, I'm sorry. There's if and else, this is straight block. But you're jumping ahead. There is one called an else if. Two different things right now. And that's not available in every language. Okay. That's a new thing within the last 10 to 15 years. Okay. You're more than welcome to use it on your own on that same line. It's doing the same thing. Okay. But if you go through, most people don't even teach this way, but then it only works on half. You know, so that's kind of why I do this. It's old school, but that's me. So if the first one's true, we calculated, right? Else, if it fell through, we knew we had less than how many pages? We knew we had more than 200, right? So on this line, we know it's more than 200. Now we're checking for 500, right? If it's true, we calculate it. If it's false and falls through to the else right here, correct? What do I need to do now? What do I know about my book pages? It's already over 500, right? Do I need to even check it? No, that's the thing that's nice about a block if state. Well, we'll do that here in a second. So right here, all I've got to do is do calculations. This is why I don't teach it right off the bat, the else if, because if you get used to saying else if, you're going to turn around and do another logical comparison. Right. So that's one of the big reasons we don't do it right off the bat. So if this case, my formula here is going to be what? Page minus what? 500. And then it's going to be multiplied by what? 0.015, right? And in this case, guess what I didn't do? I didn't put it in bracing, did I? But it will work because what? It's only one line. It's only one line. So this is me programming my whole life. I'll do this just to be nice and not confuse you as bad. But no matter what, every time you go through this little block of those nested if statements, right? Worst case scenario, old school, we'd have 3 different if statements. And no matter what, every time you ran the program, it executed how many if statements? 3. Block if statements are a whole lot more efficient because now when I go through this block, how many if statements? There's only 2, not 3, correct? If the first one's true, it does that, correct? And as soon as it's done with this, it bypasses everything. So sometimes you'll do 1 if statement. Worst case scenario, you'll do how many if statements? 2. There's not a third. And we say that's not really that difficult. Well, what if you're processing a payroll? And you have 150,000 employees. If you can efficiently cut out anywhere from 1 to 2 comparisons in your program, when you're processing 150,000 patients or people, how much more faster will your computer execute? See, we think of it's only, well, I'll only doing it for 3 people. You got to think of the long term. I mean, hey, people in Visa, you know why they carry your decimal points out to like 10 places? It's called a rounding routine. What if by putting a rounding routine on, 1/3 of your customers paid an extra penny every month? Well, if you have 30% of 10 million, that works out to be what? 3 million? I take 3 million pennies extra each month, wouldn't you? Same thing with efficiencies. If you can save that much computer time or execution time. And this is where I say, when you start talking about programming, when you go through self-taught or watch a video or this or that, they don't really go into the structure and the logistics of it. There's a difference, okay? So there we go. No matter what, we have gone through and we've determined what the cost of my book is, right? So now all I've got left to do is what? Okay, we're going to print out what? ISBN, pages, and what? Cost. Whoa, looks like Costco. And so I'm going to come through here and do this. Right? So it'll space it down. Then on my next line, I'm going to do what? Zero is going to be string, right? I'm going to scoot over a little bit more, and I know these probably won't line up. We'll mess around with them. This one's going to be what? It's going to be an integer, right? What's my number for integer? Where do we go look? Integer is just going to print it normal, I think. So I'm just going to go ahead and do this. This is just going to be 1, right? Let's see if it works. The last one is going to be the cost, right? So it's going to be 2, but I want to put what? C. What does C do? Currency, $, and decimal, right? Comma, we have ISBN, we have page, and we have cost, right? Then I need to ask them if they want to do what? We'll space down a little bit more. Do you want to quit? Yes or no? Except I left my yes off. And then I followed up with what? Nothing like capital works. Right? And that should work, shouldn't it? We have an error anywhere? Huh? Look good? Do what? It's telling me something. It's expected somewhere. So let's go back and look at it. 1, 2, 3, 4, correct? 1, 2, 3. While loop. I'm having all kinds of problems here, aren't I? There. That should take care of it. See if it works now. Let's wait and get it to run. Where's our error now? What did we do wrong? Well, that's why we're doing this. Pardon? Didn't I do it right? Yeah, it's not a logical comparison up here. This is an assignment, right? Because we're assigning a value to that variable to begin with. What are we missing though?
I feel like it's just like maybe try running it again and see if there's a problem.
We just did something wrong. Man, thing's picky, too picky for me. 1, 2, 3, 4, 5. That sounds like a good ISBN number to me, doesn't it to you? And we're at 150 page book, so it should fall through with the cost of. Hey, we're pretty close when we guessed it too. And see, so our decimal point, it wasn't a problem with an integer field, right? Okay. Do we want to quit? No. Let's go through and check. That's a great book number. Let's go at 600. So going through and looking at it, 600 is going to give me what? 100 pages at $0.015 is $1.50, right? So I should get what, 12 1/4? Yeah, you take my word for it, right? So the number of books that we have is determining what formula I use, correct? What kind of programs can we write now? I have all kinds of people that say, well, let's write this one. You know, I ask you, what kind of program you want to write? Well, can we write that? And I always say, no, we can't do that quite yet, right? No, we can't do all the lines right now because we haven't dealt with arrays or lists. But other than that, what can we do now? If I told you you have a house, you're gonna go build a house, and I'm giving you wood, nails, shingles, brick, what can you build? Structure-wise, you could probably build whatever you wanted, right? That's where we're at right now, because our major building blocks are looping, calculations, and comparisons with logic. Kind of opens up Pandora's box, so to speak, on the types of applications we can write. So now is where we start getting a little more creative each day with the programs that we write. Okay, so back to the if statements themselves. Do you understand what we're doing there? If's the universal logic command. Statement in every language, every programming language has some form of a if statement in it. There'll be a little differences between them, but they're all logic, right? We have a variable, an assignment, and a variable. Okay, if I were doing this one straight through on my own, we're going to work with it later on, but these are just simple block if statements. There are ways where we can say, if this is true and this is true, or this is true, we can start making what we call complex comparisons with and or, but we'll wait and add those later on when we do them. Okay, don't want to, the water's half clear, half muddy right now. No need to stir it up a little bit more, right? Questions? Make sense? It's just different right now, right? You guys probably got more confused with this than this. Let's modify one or two things here. I don't think I showed you this one yet. That's a neat one. Clears the screen. So now in my program, it's going to ask me the two questions. I'm going to enter it, but before I print out my answer, what's going to happen? It's going to clear the screen off and just show me the answer. So another thing I could do is come up here at the top and tell it to do what? Before I ever ask the first question. So just little things like that, right? So first time through really didn't matter, did it? But it clears it out. So it's not as cluttered, correct? Do you want to quit? No. Clears it back off. So remember that console.clear. Okay.
So in our last Tuesday, bowling thing,
Lab, yeah.
that would have been a way to make the
Each
different games actually stack up next week.
Sure.
Yeah.
Yeah, it clears everything off. So just instead of having everything all spaced out on that output screen, it would just show them one pass at a time a little bit better. Okay, that one's not real confusing, so I can throw that one in right now. All right, questions? We have lab tomorrow. For those of you in the 11 o'clock class, we got a test at 11, right? So we'll meet in the lab down the hall, and you can go ahead and boot up the machine and whatever, but at 11 o'clock, I'll come in and give you the password and we'll all test, okay? All right, I'm done. See you. I'll put an example of this out on Canvas, the one we did. See you.